Hi, everybody. Welcome to the Quarter Deck Arcade. Just a quick video to let you know what I'm doing today. As some of you know, I'm on a 4-day weekend right now, right in the middle of it. So today is Friday, and so I decided to do something that I've been wanting to do for quite some time in the arcade, and that's get a measurement of how many amps I'm drawing on each power strip. Those of you that recall, a couple of weeks ago, I talked about my power setup and the 16-port power strips that I use. Well, I was interested for a long time about knowing, how much are these things drawing, how much power are these things drawing, and should I be concerned about overloading circuits? You've read online that these things don't draw so much power, and in fact, today I did find out that they are indeed not drawing that much power, and I'm going to show you what my findings were from the tests that I ran this morning. At the same time, I also took the time to implement or install these iHome smart plugs on those power strips because it's getting to the point now in the arcade where it's becoming hard for me to reach the power button for those strips. So I at least wanted to use the iHome smart plug, and I realize it's not coming up. The color is kind of white on white. Key light is kind of putting this out of focus, but it's the iHome Flow smart plug. It's available at Walmart for $10. You can get them 2 for $20. So yesterday I went by Walmart and I picked these up, and so today I decided I was going to get this done, and I did. So let's jump into the power. So guys, the tool I use to measure the power is this. It's I can't even read the name. If you guys Google PN2000 electricity usage monitor, it'll come up. But what it looks like is this. It's just an inline plug. So you plug this to your outlet that your power strip is plugged into, and then you plug the power strip actually into the port here. And then you've got various options on the menu. It's pretty simple. You've got your up or down to cycle through the different power measurements it takes. And there's a couple of other buttons which I can't read right now, but all I did was I used the up and down arrows to navigate to amps, and then plugged in my power strip and did my tests. So look for that online. I believe this is like $20 on Amazon. I can leave a link to this in the video description, and I'll also do the Walmart link to the iHome smart plugs too if you're interested. So that's that. But what I basically did was I have three main power supply areas, and they're all on different circuits. So I've got this wall, this false wall here. Then I've got the back wall there. And then I've got against that far wall, I've got a power strip. So 3 power sources in the room. I also have a power strip in the middle of the room for the build-a-cades. That's running to the power strip on the back wall there. So that test is going to be combined, and I'll break it up and I'll break down the numbers for you accordingly. So let's get started. First of all, I'm going to bring up, I already showed the box to you, but that's what I'm using for the smart plug. And it works with an app called Genie, and it also works with, it says on the box, it works with Google, or works with Alexa and the Google Assistant. So more power to you if you want to do that. Let's get started here. So here is a look at, I've got it set for amps right now, and right now you can see it's set to 0 because the power strip is turned off. I've plugged in the extension cord from the power strip into the box, and the box is connected directly to the outlet. Again, all my 3 power sources are on separate circuits. Probably way overkill, and honestly, I did find out that it is kind of overkill. So, but I can live with it. As long as I'm running off 3 different circuits, I know I've got plenty of power. So So right now, this is the device at its basic startup, 0, no power being drawn or anything. So let's keep moving through the pictures here. All right, so this power source is for the false wall line of arcades here. The wall with Galaga and Golden Tee and the Defender Party cage. So very little on this circuit right now. Included in this number that you see before you, there are the LED lights on the back of each arcade and some LED artwork that I have hanging the Galaga ship. So that's all drawing power through this outlet. And as you can see, it's only drawing 1.7, I'll round it up, 1.75 amps on a 15 amp circuit. So not a heavy draw on this particular circuit, to be sure. But one thing I forgot to test in this round of testing is the black light, because there's a black light in the ceiling that's plugged into this same strip. So I'll show you that number towards the end. Actually, I'll show that number to you towards the end, because I'm kind of going in sequence here. All right, so that's power strip number 1. I call that the south strip, or the south power. All right, so let's keep moving forward. So next is this second circuit. This outlet is right by my my power panel. So my breaker panel. This is another circuit, separate circuit. And as you can see, I've plugged it in. The strip is off. And this particular power source goes to the back wall there. So where my Legends pinball is now connected, this T2 Space Invaders, the At Games Legends Ultimate, and the Star Wars, and then the Star Wars pinball. All of that whole back wall is plugged into this particular power source, and the Build-A-Cades in the that strip are also plugged in through here. So let's go through this, because this is very interesting. This first test that I did is without the Build-A-Cade strip. So let's keep moving forward. So I think I lost myself here. Hang on. Go back. And we're back at 0. All right. Okay, here we are. All right, so as you can see, I'm at about 2.89 amps, 2.89 amp draw, and this is for the Legends Pinball, the T2 Space Invaders, the At Games Legends Ultimate, the Star Wars, and the Star Wars Pinball. So all of those combined are drawing 2.89 amps. Not bad. Doing pretty good. So let's throw in the Build-A-Cade strip and turn all the Build-A-Cades on and see what that draw goes up to. 3.53 amps total. So that's with that whole back wall, and then these Build-A-Cades in the middle. Oh, Pong's included in this number as well. I'm sorry. Pong is included in the number that we saw before, 2.89. Pong is also included. The Pong pub table is included in that number. So adding in the Build-A-Cades to all of those back wall cabinets, the number goes up. The amp usage goes up to 3.53. All right. So interesting, very interesting. Still low power draw. On a 15 amp circuit. These are all 15 amp circuits. So again, accumulating this data was very fascinating to me. All right, now let's move to the back wall here, where I just moved a whole bunch of other stuff into it. So let's go. So as you can see, I got it down to 0 because the strip's not on. And this outlet is sandwiched between two cabinets, so the picture might be a little blurry because the light is kind of dim back there, but you can see it's at 0. All right, so with all of the cabinets on along that back wall, and with all the LED artwork, my Let's Go sign, my Atari LED sign, the Pac-Man little nice thing over there, and then the game room LED sign, all the artwork, all the LED lights, and then the cabinets involved in this number would be the Atari Tempest, would be Tron, Joust, Centipede, Dig Dug, the Pac-Man Deluxe, and the Class of 81 Deluxe. So all those machines fired up, added up to about a 2.62 amp draw. Interesting. So not bad, not a heavy power usage. So pretty happy with that. So moving right along, I'm going to show you the next numbers that I show you. I went back because I forgot to add in the black lights for the measurements. So all the measurements I've shown you up to now are measurements without the black lights. So let's go back to the first circuit. And where it was, well, the number before was like it was 1.7 something, I believe. So what you see here is with one black light LED strip turned on. So the power usage on circuit 1 goes up to 2.08 amps. Still, those LED black lights don't use a whole lot of electricity, as you can see. So that's circuit 1. Let's jump over to circuit 2, which is, again, is just one LED black light, and that power usage jumps to 3.79 amps. Still very low, not even half the rating of the circuit. So 15 amps. You're still doing pretty good. And then lastly, the third circuit and that has two black lights connected to it. So two black light LED strips, and that power usage jumps to 2.97 amps. So very interesting numbers. I bought this handy dandy little tool. For Christmas, I used to be heavy into Christmas decorating. I have several outlets on the outside of my house. And when I wanted to know if I was overloading a circuit, I'd plug this thing in, and it would tell me how many amps I'm drawing and whether I was in danger of tripping the circuit breaker. And that's how I kept things balanced in the yard. So very fascinating, very interesting information. So again, I'll leave a link in the description for these handy devices. This power meter. Everybody, I think, should have one in their house, just in case they're curious whether or not they've got too much on a circuit. It's cheap, it's $20, so it's a good tool to have around the house. And then these iHome, these seem to be working well. I've used these previously on the black lights, turning them off, on and off through the app in my phone, and then now I'm using them to cut and apply power to the arcade without having to bend over and turn on power switches. So that's it. That's all I have. Thank you for watching, and everybody have a great week and a safe week. And always remember that I got next.